Hi guys, welcome back to Math with OG. In this video, we'll be talking about equal sets. Now, what are equal sets? As you can see on the board, two sets A and B are said to be equal if they have the same elements. So when you have two sets having exactly the same elements, we say that both sets are equal. A set having element ABC, another set having element ABC, obviously they are equal sets. Now let's see an example. Set A is a set containing 2, 3, 4. This is written under your roster method. Now a set B is equal to x such that 1 is less than x less than 5. That means x is a number between 1 and 5. Not only that, x is an element of natural numbers. That means x is an element of positive integers. That is positive whole numbers. If that's the case, what are the positive whole numbers between 1 and 5? You have your 2, 3, 4. So if I'm to change this guy to my roster method, I think we've done that. How to change from rule method to roster method. My set B will also be equal to whole numbers between 1 to 5, between 1 and 5 is simply 2, 3, and 4. So you can see set B is a set containing 2, 3, 4. Set A is also a set containing 2, 3, 4. So we say that both sets are equal. Now we have another example on the board. Set P is a set containing 2, 5, 7, and set Q is a set containing 2, 5, 5, 7. Remember, we've agreed that you don't count distinct elements in cardinality. So before we get to the cardinality, you can see that the elements here are 2, 5, and 7, or rather you count distinct elements in cardinality, but you don't count the same element. That means if an element is appearing twice, you don't count them. So we'll get to that when we want to talk about this. Now, if P is equal to 2, 5, 7 and Q is 2, 5, 5, 7, the elements here are 2, 5, and 7. The distinct elements here are also 2, 5, and 7. So therefore, P is equal to Q. Now that we've known how to get equal sets, there's one last thing, connecting equal set and equivalent set, or let's say a relationship, and it is that all equal sets are also equivalent sets. So once you know that two sets are equal, you should rest assured that the both sets are also what equivalent. So let's see this as an example. 2, 3, 4, 2, 3, 4, they are equal. Are they equivalent? Yes, because the cardinality here is 3 and the cardinality here is also 3. Similarly, in this case, 2, 5, 7 cardinality is 3, 2, 5, 5, 7 cardinality is also 3, because we've agreed that cardinality is the number of distinct elements. That is 2, 5, and 7. So these two sets are equal. It means that they are also equivalent. However, not all equivalent sets are equal. Not all equivalent sets are equal. If I have a set, okay, let's use set Y and Z. If I have a set Y to be equal to ABC, and I have a set Z to be equal to 1, 2, 3. As you can see on the board, these two sets are equivalent because the cardinality here is 3, the cardinality here is 3, but not equal. So two sets can be equivalent and not equal, but two sets cannot be equal and not equivalent. So once two sets are equal, the two sets are also equivalent. Now that we've known that, so I can write here, if A is equal to B, then the cardinality of A must be equal to the cardinality of B. And if that's the case, A will be equivalent to B. So note that all equal sets are equivalent sets, but not all equivalent sets are equal sets. So that's all you need to know about equal sets. Now, next video, we'll be looking at other aspects of sets. Now, if you've liked this video, kindly use the like button. Don't forget to subscribe if you've not yet done so. And don't forget to share to friends. And you can leave your comments if you feel there's any error in our solutions or in the explanation. And also leave your comments if you have any question you wish to ask. Thanks for watching once more. See you guys in my next video.